Welcome to Monkey Physics IIT JEE NEET Foundations.
Yeah. So in other example, in the coming example, what we are focusing is if a whale is rolling on a floor. So in this model, they ask us to find out the distance and displacement. Example, look at here, this is the wheel. Now here is the floor. This is a contact point P, and this is Q, and this is R, and this is S. Okay. Now let us assume the wheel is rotating like this. It's rotating about this axis. It's a rolling. So after completion of half rotation, what happened to this? This point, after completion of half rotation, this point is going to move here. This is becoming P, and this Q. It's a rotating half, na? So exactly, previously here is a Q. Q is going to come over here, and S is here. S is coming over here because move opposite side, and R is coming down here. This is what for half rotation. Half rotation. Is it clear? Yeah. Then they are asking for a half rotation. Find distance and displacement of the contact point P. Contact point P. Distance and displacement of contact point P. Now, one thing we should understand here. First, when we focus on distance means previously the P is touching the ground, and after that it has moved, isn't it? So when it has moved, look at this part. This total length of the path. This total length of the path, we all know clearly, it is a pi r, isn't it? It is half of the circumference. And what is the radius of the circle? So radius of the circle, we can take it as r. So it is given as pi r. Now how to calculate the displacement? Here it lies. Now when you unstretch it, I mean it is in the stretched form, folded form. When you unstretch it, bring it down and make it straight line. So this is going to give you pi r. Why? Because this length itself is forming like a bending curve. So if you unfold, if you just remove the bending of this curve and making it straight line, it falls like this length. And this length we know clearly pi r. And what about this distance? This distance is nothing but 2r. Isn't it? Now it's clear. Previously the point is here, and after a half rotation the point is here. So you can move from here to here. When you draw, this is going to become the displacement. Therefore displacement, look at here, this side, root over Pythagoras theorem I am applying. So pi r whole square plus this 2r whole square. Isn't it? Right angle triangle. So we are applying Pythagoras theorem. This is hypotenuse. So root over side square plus side square. Now s bar is equivalent to root over what I am going to take, pi square r square plus 4 r square. So s bar is equivalent to root over r square, if you take common, pi square plus 4 into r square. Now if I'm sorry, in the notation, I'm really sorry. Yeah, it's just for so why should I change? Means because I have given the notation r to this point here, so that is why I need to change. Otherwise, will be confusing. So if radius of the circle is equivalent to 1 meter, suppose unit distance they have given, then the displacement, the expression, it is nothing but pi square plus 4, and this is the answer. Okay, yeah. Now next example, if they ask us the displacement for the point Q, okay, displacement for the point Q. Of course, the distance means for point Q also half rotation. It's the same as previously it should be here and it has traveled like this. It's a pi r only. This is distance traveled by any point for half rotation. Distance traveled by P, pi r. Distance traveled by Q, pi r. Distance traveled by R, pi r. By S, pi r only. But how to calculate the displacement? So displacement, I'm talking about displacement of Q for half rotation. Half rotation of the wheel. Half rotation of wheel. They ask us to find what is this. Now look at here. What is this distance and what is this distance? I'm sorry, r. Isn't it? Of course, this is 2r. I'm removing this. This is 2r. Yeah. Now look at here. From here to here, we all know already. How much is that? Pi r. What is this? Pi r. Now look at here, r plus pi r plus r, and that is a displacement of q. Therefore, displacement of q is nothing but r plus pi r plus r. It is nothing but pi r plus 2r. And if r is equivalent to 1 meter, displacement of q is nothing but pi plus 2. That's all. Now, what about displacement of s? This one you should calculate. This straight line. Displacement of yes. By this time we come to know. Next example, displacement of s is equivalent to how much? Otherwise we can notation if it is giving you confusion. So displacement of s for half rotation. For half rotation. So now how do you take displacement of s for half rotation? Look at here. This total is pi r and this is r, 2r. Now out of this pi r and r we have to subtract, isn't it? Then what happened here? Displacement of s is equivalent to, it's a pi r minus 2r. Pi r minus 2r. And of course, if r is equivalent to 1, so displacement is nothing but pi minus 2. This is what the answer. Yeah. So I'm extremely sorry. The notation keep on changing with the smaller with capital R. Anyway, later on we changed it. I'm sorry for the inconvenience. Thank you.